In this video, we're going to talk about writing in polar form. Now, when we say polar form, we talk about something written in the form of z is equal to r cos theta plus imaginary sine theta, or z is equal to r cis theta. Now, these two means exactly the same thing, but this one here is a shorter form of this. So C stands for cos, I stands for imaginary, and S stands for sine. So all this can be written as r cis theta as well, and both of this is known as the polar form. Now when you are given a complex number which is in the form of z is equal to a plus bi, you can write that complex number in polar form. Now we're going to do an example. In this example 1, we have to write z is equal to minus 1 minus root 3i in polar form. Now you can notice here that we have a complex number. We have a complex number in the form of a plus bi. Z is equal to minus 1 minus root 3i. Now we have to write this in polar form. We have to write in the form of z is equal to r cos theta plus imaginary sine theta, or in the form of r z is equal to r cis theta. Now notice that we have two things here, r and theta. Therefore we need to first find the value of r, and then later on we are going to find the value of theta. Now it is always good to first sketch our complex number in an Eigen diagram. If we draw this complex number in an Eigen diagram, it will look something like this. We have our real of z and we have our imaginary of z. Negative 1 is somewhere here, and negative root 3i is somewhere here. So if we have to plot this, is negative 1 and negative root 3i. So our z falls somewhere here. Now let's first find the value of r. This is what we called the value of r, the length. So let's find the value of r. R will be equal to a squared plus b squared, and taking everything root. So the value of a here is, a is the real part, so real of z is minus 1, and b is the imaginary part, which is minus root 3. So a squared will be minus 1 whole thing squared plus negative root 3 whole thing squared, and then taking everything under the square root. Now if we evaluate this, negative 1 squared is 1, and negative root 3 squared is positive 3. Now we have to take the square root. This will be root of 4, and root of 4 is 2. So our value of r is equal to 2. So we have already found the value of r. Now we have to find the value of theta, which is this. Now theta is basically from the positive real axis, this, or we can say from the negative real axis. So there is two possible ways we can find the value of theta. Now to find the value of theta, we have to take tangent theta, and tangent theta is opposite over adjacent. Now if we make this triangle on the side, this will look something like this. This is the value of theta that we have. This is -1 and this side is -√3. Now when we are finding our acute angle, we always disregard the negative sign. So the opposite side for this will be +√3 and the adjacent side for this will be +1. So that will be tangent theta is equal to √3/1. And when we take the theta, we have to do tangent inverse of √3/1, and theta comes to 60 degrees. But this is not our theta that we are talking about. We need the theta from positive real axis. So what we are going to do is we are going to add 180 degrees to that, because from here to here is 180, and this is the part that we have found. So we'll say 180 plus theta, which is 180 plus 60 degrees. 180 plus 60 is 240 degrees. So we can write this in polar form. Z is equal to 2 cis 240 degrees, or we can say Z is equal to 2 cos 240 degrees plus imaginary sine 240 degrees. Now there is an easier way to do this if we use our calculator. The calculator method is very simple. If you are using a FX MS82 calculator, you can simply use it and find the value of R and theta. Now your complex number is Z is equal to -1 minus √3 I, where your A is -1 and B is minus √3. Now if you have to find the value of R, you can say POL open bracket -1 comma -√3 close bracket, and then you can press equal. So this is how you're going to do it. You can press POL -1 comma -√3 close bracket, and then you can press equals. You'll get 2 as your R. Here you got 2. This is how we do it, the calculation. This is the calculator method. Then if you have to find theta, you can press RCL tangent and you'll get the value of theta. So to this result you can press RCL and you can press tangent. You'll get your value of theta, -120 degrees. But here you can see you get -120, and here you got 240. These two are same angles, but the only difference is the calculator method has taken from the negative real axis. So if you come to this point here, from this direction, from the negative real axis, this will be 120, -120. But if you take it from this angle, it will be 240 degrees. But you are arriving to the same point. So whether you come from this side or you come from this side, the angle is still the same. -120 and 240, they are same. right? So you can also write this as z is equal to 2 cis negative 120. Let's do another example. We have to write z is equal to root 2 plus root 2i in polar form. So this is in the form of z is equal to a plus bi, z is equal to root 2 plus root 2i. So here we can notice that our value of a is equal to root 2 and our value of b is also root 2. Now if we draw this in a complex plane, this will be real of z, this will be the imaginary of z, and root 2 is somewhere here, and root 2 is here. So our z falls somewhere here. We can find this angle. Now our angle falls in the first quadrant, and this will be our value of r, the size. So let's first find the value of r. R is equal to a squared plus b squared, and take everything under root. So r is root 2 squared plus root 2 squared, and everything under the root. So you can cancel this, you get 2, plus you can cancel the root with the 2, get 2, take the square root. 2 plus 2 is 4, and root of 4 is 2. So our value of r is 2. Now to find the angle, let's use tangent theta. Tangent theta is equal to opposite over adjacent. Our opposite side is root 2 and our adjacent side is root 2 as well. So tangent theta is equal to root 2 over root 2. To find the value of theta, we take the inverse of it. So tangent inverse of root 2 over root 2, and that comes to 45. Yes, it is 45 degrees. So we can write this in polar form. Z is equal to 2 cos 45 degrees plus imaginary sine 45 degrees, or we can say Z is equal to 2 cis 45 degrees. Now this is the calculation method. Let's use the easy approach, calculator method. Now for calculator method, if you want to find the value of r, value of r will be POL open bracket root 2 comma root 2, and then you press the equal sign. So you have POL and then root of 2 comma root of 2 bracket and press equals. So there you getting 2, and in the calculation method you also got 2. Now to get the value of theta, what you can do is you can press RCL tangent, and then you will get the value of theta. So to this, just press RCL and tangent, so you're getting 45 degrees. This time the calculator did not come in the opposite direction because there was no need. You can only arrive to this point in this direction, or if you come in this way, you'll have to take the negative approach. So we can write this z is equal to 2 cis 45. So we have learned both approaches here. This is the calculator method, which is the easier one, we can say easier approach. This is very easy, and this is the calculation method. So it's always good to know both the methods and write in polar form.